All right, we're going to do a real quick video here on Stepwise. What we're going to do is basically just use the Stepwise function to determine which of the IVs, which of the predictors are significantly contributing to the DV. Okay, so we're not going to run the entire regression like we did the hierarchical. You can do that if you want. So, but let's go ahead and get started here. We're going to go to Analyze, Regression. Had a big lunch here, you guys, so I'm kind of trying not to fall asleep. Linear. And we want stepwise. So you go to method, we're going to type in stepwise. Our DV is job satisfaction. And all of these other 14, you simply kick into the IV box, okay? So we go and we check the R-squared descriptives, partial and parts, collinearity, and of course the dreaded Durbin-Watson. Plots, Z-pred goes on bottom. Z-resid goes on top. I knew that. Continue. Save. The save is the button that has the Mahalanobis. And there's nothing under options. So we're going to click OK. We're going to refit our window. Please hold. All right, here's the first box. These are the means and standard deviations of each of the variables. There's the DV and all the IVs, okay? And here's the correlation. Be very, very careful. You can have a lot of strong correlations in the correlation matrix, but they will not be part of the regression model. So don't overly worry about the correlation box. And let's go back down, and here is the money. So according to the stepwise regression by SPSS, it says there's only 2 of the variables, 2 out of the 14, that are significantly affecting job satisfaction. So the first one is the work stress, and the second one is salary. And let's look at our 2. So it made 2 separate models. The first one was simply, so it made 2 models. Model number 1 was strictly with work stress. And look at that R-squared. Bam. So in other words, about 63% of the job satisfaction can be explained simply by work stress in the first model. The second model is work stress and salary. And look how big that R-square is. So I'm going to jump over here to the R-squared change. So when we added just salary to the model, that could explain an additional 22% of the variance in job satisfaction. So these are your 2 main players, would be work stress and salary. So did you get a feel for that, for the stepwise? The non-significant contributors were automatically kicked out. So basically you have a 2 predictor, 1 criterion model. Let's just scroll down to the ANOVA box. So here's the first regression model, and that's simply with work stress, and it was a significant regression. The second model was the work stress and the salary. Again, that was a significant one. And here's your coefficient box. We're going to look at the beta weights. So the work stress, negative 0.55. That's pretty big. So what that means, when stress goes up, job satisfaction goes down, and vice versa. The next one is salary. That's a big positive one. So in other words, when salary goes up, job satisfaction goes up as well. All right, so we're going to skip over the parts and the partials. All right, forget about the excluded variables box. Collinearity. Again, we're not going to worry about too much about the assumptions. You can go ahead and do that. I will mention them real fast, but I'm not going to show you how they're done. You could watch one of the other videos. But what are we looking for? We're looking for the maximum Mahalanobis distance. It's only 6.6, and that means that there's no outliers because with 2 variables, the maximum critical number is right around 12 or 13, so nothing there. And we're going to check our homoscedasticity. You're going to click on that. You're going to add the lowest line. Remember, we have a very small sample size, so I would not be surprised to find this assumption violated. And it is violated, right? This should be basically a flat line. So, again, it does look like we violated the assumption of homoscedasticity of the data, but again, because we've got such a small sample size. But I think that's just about it. And so I hope you enjoyed the stepwise regression. Co-pilot, you got something to say? Good co-pilot, good co-pilot. All right, MGZ out.
下面这首歌献给我们亲爱的瑞瑞，瑞瑞你要好好听哦，哒哒哒哒哒哒哒哒哒哒。